Next, let's look at the last submodule, which is scaling agile methods. Agile methods were developed for use by small programming teams that could work together in the same room and communicate informally. They were originally used for the development of small and medium-sized systems and software products. Small companies without formal processes or bureaucracy were enthusiastic initial adopters of these methods. Of course, the need for faster delivery of software, which is more suited to customer needs, also applies to both larger systems and larger companies. Consequently, over the past few years, a lot of work has been put into evolving agile methods for both large software systems and for use in large companies. Using an agile approach presents a number of problems. First, the informality of agile development is incompatible with the legal approach to contract definition that is commonly used in large companies. Second, agile methods are most appropriate for new software development rather than for software maintenance. So far, the majority of software costs in large companies come from maintaining their existing software systems. And third, agile methods are designed for small co-located teams. So far, much software development now involves worldwide distributed teams. Agile methods have to evolve to be used for large-scale software development. The fundamental reason for this is that large-scale software systems are much more complex and difficult to understand and manage compared to small-scale systems. Six principal factors contribute to this complexity are: first, large systems are usually systems of systems or collection of separate communicating systems where separate teams develop each system. Frequently, these teams are working in different places, sometimes in different time zones. It is practically impossible for each team to have a view of the whole system. Consequently, their priorities are usually to complete their part of the system without regard for wider system issues. Second, large systems are brownfield systems, that is, they include and interact with a number of existing systems. Many of the system requirements are concerned with this interaction and so don't really lend themselves to flexibility and incremental development. Political issues can also be significant here. Often the easiest solution to a problem is to change an existing system. However, this requires negotiation with the managers of that system to convince them that the changes can be implemented without risk to the system's operation. Third, where several systems are integrated to create a system, a significant fraction of the development is concerned with system configuration rather than original code development. This is not necessarily compatible with incremental development and frequent system integration. Fourth, large systems and their development processes are often constrained by external rules and regulations limiting the way that they can be developed, that require certain type of system documentation to be produced, and so on. Customers may have specific compliance requirements that may have to be followed, and this may require process documentation to be completed. Fifth, large systems have a long procurement and development time. It is difficult to maintain coherent teams who know about the system over that period, as certainly people move on to other jobs and projects. Lastly, large systems usually have a diverse set of stakeholders with different perspectives and objectives. For example, nurses and administrators may be the end users of a medical system, but senior medical staff, hospital managers, and others are also stakeholders in the system. It is practically impossible to involve all of these different stakeholders in the development process. Scaling agile methods has closely related aspects. First, scaling up these methods to handle the development of large systems that are too big to be developed by a single small team. Second, scaling out these methods from specialized development teams to more widespread use in a large company that has many years of software development experience. No single model is appropriate for all large-scale agile products, as the type of product, the customer requirements, and the people available are all different. However, approaches to scaling agile method have a number of things in common. First, a completely incremental approach to requirement engineering is impossible. Some early work on initial software requirement is essential. You need this work to identify the different parts of the system that may be developed by different teams and often to be part of the contract for the system development. However, these requirements should not normally be specified in detail. Details are best developed incrementally. Second, there cannot be a single product owner or customer representative. Different people have to be involved for different parts of the system, and they have to continuously communicate and negotiate throughout the development process. Third, it is not possible to focus only on the code of the system. You need to do more upfront design and system documentation. The software architecture has to be designed and there has to be documentation produced to describe critical aspects of the system, such as database schemas and the work breakdown across teams. Fourth, cross-team communication mechanisms have to be designed and used. This should involve regular phone and video conferences between team members and frequent, short electronic meetings where teams update each other on progress. A range of communication channels such as email, instant messaging, and social networking system should be provided to facilitate communication. And fifth, continuous integration, where the whole system is built every time any developer checks in a change, is practically impossible when several separate programs have to be integrated to create the system. However, it is essential to maintain frequent system builds and regular releases of the system. Configuration management tools that could support multi-team software development are essential. It can be difficult to introduce agile methods into large companies for a number of reasons. First, project managers who do not have experience of agile methods may be reluctant to accept the risk of a new approach, as they do not know how this will affect their particular projects. Second, large organizations often have quality procedures and standards that all projects are expected to follow, and because of their bureaucratic nature, these are likely to be incompatible with agile method. Sometimes these are supported by software tools, example requirement management tools, and the use of this tool is mandated for all projects. Third, agile method seems to work best when team members have a relatively high skill level. However, within large organizations, There are likely to be a wide range of skills and abilities, and people with lower skill level may not be effective team members in agile processes. Finally, there may be cultural resistance to agile method, especially in those organizations that have a long history of using conventional system engineering processes. Huge amount of software engineering effort goes into the maintenance and evolution of existing software systems. However, where maintenance involves a custom system that must be changed in response to new business requirements, there is no clear consensus on the suitability of agile method for software maintenance. Three types of problems can arise, including: first, lack of product documentation; second, keeping customers involved; and the last one, development team continuity. To address these problems, most large agile software development projects combine practices from plan-driven and agile approaches. Some are mostly agile and others are mostly plan-driven, but with some agile practices. To decide on the balance between a plan-based and an agile approach, you have to answer a range of technical, human, and organizational questions. These relate to the system being developed, the development team, and the organization that are developing and procuring the system, as shown in the figure. Agile combines the best of both worlds, injecting agile methodologies into a loose waterfall process to increase speed, decrease cost, and improve quality. Table shows waterfall role and agile role in order to make them work together. As many of today's projects tend to be larger and more complex, a one-size-fits-all approach is being replaced by a mix of more traditional waterfall methodologies and modern strategies that can be adapted more rapidly to keep up with the various processes of project management. There is an increasing demand for hybrid project managers, and very often one project requires multiple managers. In order to unlock value and enable quick reaction, organizations must be fully integrated and embrace cross-team projects. Hybrid or mixed project management is partially waterfall and partially agile. Most of these hybrid projects are run in Jira and use an extra project management application, example Big Picture, to avoid difficulties that mixed project management in plain Jira software or in Jira Core would bring. For project managers, blending methods requires extra attention. They must constantly seek out education in the latest method and be able to steer projects with clearly defined methodologies, all while leaving room for incorporating aspects of other, more ad hoc approaches. It is imminent to know which part of which methodology will serve the specific case, team, time frame, outcome, and so on.